Hey there. So in this video, we're going to be talking about systems of equations and inequalities, but more in terms of application problems. And I wanted to point out before we got into a couple of the problems that you have a toolkit also in the back of your workbook. If you go to additional resource pages, you'll find it. This one is called Steps to Set Up and Solve Systems of Equations and Inequalities. Okay, so I wanted to kind of just review this first, and I wanted to point out that these application problems are very similar to the application problems that you've been doing so far this quarter, with just a couple of differences. We, of course, always use the problem-solving process. You know, whether it's 5 steps or 6 steps, it's the same idea, same kind of pathway that we go through. Number one, we're familiarizing. We still define our unknowns. And of course, we've got 2 unknowns, right? So we can have an x and a y or whatever variables that there are. And we list the known information. Okay. One of the big differences here, though, this is different from everything, is that we, of course, are looking for information on the inequality sign. Okay, we want to figure out what is the inequality sign. And if you guys remember also in your work with inequalities in Unit 13, you do have an application or a additional resource page that was given to you. There's also one in the back of the book that goes over what the wording might be to, to give you, or maybe to signify or symbolize whether we use a greater than or a less than sign or equals to, that sort of thing. So you can look for that toolkit as well to help you. This is also different. We are going to find 2 of the given categories. It'll be something like total number of items, and then there'll be information on cost. And the idea is we're going to be writing 2 equations or inequalities using that information that's given. And we need to keep it into those 2 separate categories when we're writing that information. And we're going to practice that today. We're going to be solving like usual. And of course, we're going to be graphing. If it's a system of inequalities, we want to make sure that we're going to be shading the correct region, that sort of thing. Okay, so and then our check. So our check on a system of equations, remember that it's a point. It's that one point basically that makes both of the equations true. The system of inequalities, we've been taught in the past to just check a point that's inside the overlap region, and then we can check one point that's outside that region just to make sure that we have shaded the correct region. Okay, so there's just a couple of minor changes, minor differences, mainly this step number 2 here. Okay, that's for me, that's kind of the biggie. All right, so I would like to practice this on a couple of problems. This one is number 16 on worksheet 16A, and right here we're dealing with systems of equations. All right. One day the campus bookstore sold a total of 25 coffee mugs and calculators. The mugs sold for $5 each and the calculators sold for $20 each. In all, $350 was taken in for the mugs and the calculators. How many of each type were sold? All right, so we are kind of familiarizing ourselves with this problem. We want to make sure we're defining our knowns and listing our unknowns. So we have this problem actually helps us a little bit, and it's saying, okay, we want you to define your variables. Let x equals one particular thing and y equals the other. This is kind of a random thing. You guys don't have to put your information in either particular way. We could in fact use an M for mugs and a C for calculators. We didn't have to use an X or a Y, but let's go ahead and use our X for the mugs. Let X is equal to the number of mugs, and Y can be then the number of calculators. Okay, We know here we've got mugs and we have calculators. And it's asking us to write a system of two equations and two variables. And if we think back in our steps here, before we do that, we need to find our two given categories before we can start writing those steps. Okay, so let's kind of go back through this problem and see if we can figure that out. All right, well, we've got some information here. Mugs sold for $5 each, calculators sold for $20 each. In all, there was $350 taken in. And up here we have a total of 25 coffee mugs and calculators. All right, so if we were to break this down into two categories, in fact, if I were to kind of go back and maybe use a different color here, you guys can see, oops, well, that did not help. Let's actually choose a different color, there we go. Total of 25 coffee mugs and calculators, right? This particular bit of information is really talking about number of items, right? But you can see everything else is in terms of dollars, right? So the second category has to do with cost, right? So we have our two categories. So let's just write them. We've got our two categories. Our first category is going to be items. And we need to come up with an inequality, or I'm not, sorry, not an inequality, we're doing equations. And equations based on the number of items. Well, if we know that the total number of mugs and calculators equals 25, and we know that x is equal to mugs, and y is equal to calculators, we can say that all my mugs plus all of my calculators has to equal 25. All right, so we have one of our equations. And now we need to write another equation based on cost. And here's another thing I want you guys to keep in mind, that one of your categories will be weighted. It'll either be weighted by cost or it'll be weighted by something else. Okay, if you were talking about maybe a basketball game, I know there's a application problem in here for basketball game or hockey game. So if you have free throws that are 1 point each, or a regular basket which is 2 points each, the weights would be 1 for every x, let's say, is a 1 point or a free throw, and you would weight your y, which would be your regular shot, at 2 points. So they're weighted somehow. And in this case, we can see that we are going to be weighting the mugs at 5, right? So for every x that was sold, for every mug that's sold, they're bringing in $5. For every calculator that's sold, they are going to be bringing in $20, right? And in the end, when they collect all that money to see what they bring in, they're going to have $350. Okay, so we know that we've now got our two categories that are based on, our two equations that are based on those two categories that are given in the problem. Okay, so we're asked to graph both of these so that we can find the solution here. So let's do that. We can graph any way that you choose to. You guys can set up a t-table. You can rewrite these above. If these were inequalities, I would highly recommend that you rewrite them in standard form, just in case you have a flip of your inequality sign. But in this particular case, we can do what we want. And you guys can see the x plus y. This equation here is set up really well for just finding our intercepts, right? This is a super easy one. If x is 0, y is 25. If y is 0, x is 25. So right here we have our coordinates for that one. Okay, we can do the same for the second equation. Oopsie. Let me just choose a different color for that. 5x plus 20y equals 350. All right, let's make our intercept table. If x is 0, oopsie, 350, then I'm going to have this 5x is going to go away, right? And I'm going to divide by the 20. And if I take 350 divided by 20, that's going to give me 17.5. Not a nice number, but it works. No problem. All right, let's do it again. 5x plus 20 divided, or 20 times y. Let's just plug our 0 in there. All right, we can see that's going to give us a 5x is equal to 350. Well, 35 divided by 5 is 7, and then we'll add that 0. So x is 70 when y is 0. Okay, let's get rid of this so that we've got a bit of room over here in our graphic. It looks like we've got some numbers that are pretty high here. So this is also very helpful when we're working on trying to scale or find the dimensions and the scale of our graph here. We need to kind of know how to do that based on the numbers that we're going to have to graph. Now, one point I want to make here, guys, is that remembering up here that we chose these x's and y's at random, right? We chose them at random, but we did choose mugs for our x-axis. Therefore, we're going to want to make sure that we put our mugs down here on the x-axis. This is going to be number of mugs. It is a random thing. You guys could have chosen the opposite, and it would have been fine to have your calculators on the x-axis and your mugs on the y-axis. Doesn't matter. Okay, cool. So we got both of those labeled. Now, if we are looking at this equation number 1, right, we know we're going to go from 0 to 25. So our x-axis and our y-axis both have to go to 25. If we're looking at equation number 2, we see that we've got to go to 70 on our x, and we have to go just to 17.5 on our y. So it looks like our x's, if we're looking at that, let's just use this. So our x's need to basically go from 0 all the way to 70. That's our high and our low numbers. So let's figure out how many etch marks we have. Looks like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so if we went by tens, that's 150. I think we can go lower than that, right? We can definitely get there by fives for sure. That's actually going to give us 15 times 5 is 75. So I think we're okay because we only need to go to 70. So that kind of helps us with how we figure out the scale here for each one of these. So we've got 5, 10. I'm going to just skip just so we have, you guys aren't waiting on me to do all that. 50, 60, and 70, and of course 75. Oops, wrote the wrong number there. 70. All right, good. And our y-axis, let's look at that. So we know that y is our calculators. We have a low number of 0, a high number of 25, because 17.5 is in the middle there. So we're good there. If we wanted to keep it consistent, we can just go by 5s. If you guys wanted to go by 10s, you could do that. That would be even harder. You could go something smaller. You could maybe go by 2s or something like that. I am going to just keep it simple. I think I've got plenty of room to do what I need to do, so I'm just going to go by 5s as well. 10, 20, and I know I don't even need more than that, so I can stop there. You guys can finish if you want to, no problem. All right, so I'm going to go ahead and graph my first equation here. I know by my intercepts. Now, one other comment here. Remember that this graph is just quadrant number 1. Remember, on a coordinate grid, we have 4 quadrants, but we don't need any of the other quadrants because everything is positive. So in most application problems, you're just using quadrant 1. All right, so we have 0, 25 right here, and 25, 0 is right here. Okay, so that's that equation. And if I were to graph my second equation, here I've got 0 and 17.5. It's a little harder to do. It's about right there. And then 70, 0. All right. So, whoa, bad. Definitely a little bit of a challenge for me on my iPad. It's okay. I'll go back here. I'm gonna try that again, you guys. All right, that was at least a bit better. This one was a little high, I think. There we go. That looks a little bit better. Okay, now, one thing for you guys to remember here, that a graph is always an approximate. You can see just by graphing it off just a teeny bit, you could get a different number. But we can see that this looks like it hits, that it crosses right at 10, 15. Okay, well, how can we tell for sure that that's the right intersection? Well, we check it by plugging it into both points, right? That's how we would make sure that it is correct. Okay, so we can do that. I didn't really leave myself a whole lot of room, but I can try. I can try to do that. So 10, 15, remember this is our x, this is our y. Okay, so this is actually saying that 10 mugs plus 15 calculators equal 25. Well, that's pretty simple. We know, yep, that works. And over here, we would have our 5 times our 10 mugs plus 20 times our 15 calculators is going to be 350 bucks. So we've got our 50, and then it's going to be 300. And sure enough, that actually checks out as well. So we know that this solution right here is correct, right? And basically, what we really need to do is kind of go back and make sure that we are answering the question. I know there's a lot going on, a lot of highlighting, a lot of stuff going on in this problem that I've already done so far, but I'm going to come back and remind us of what we were supposed to answer. How many of each type were sold? Well, this is our answer right here. And we need to verbalize that in a sentence at the end. So I'm kind of out of room, so I'm going to write right on my graph, right? So we know, though, that the solution is 10 mugs and 15 calculators. Okay, and that's it. So that is an example of a system of equations application problem. We will actually be doing more in a later video. I will be doing more of those. I do want to skip ahead though and just do one of the systems of inequalities application problems. And I think this is the one I wanted to do. Let me just remind myself here. Yeah, I'm going to do the hockey one. Yeah, this is a good one. All right, so this is on your worksheet 6B. Okay, and reminding ourselves this is a system of inequalities, not equations. So we're going to be coming up with inequalities here. All right, so remember with our steps, we're going to read through the problem and we're going to try to isolate the important information. So let's start there. The Skating Stars believe that they need at least 60 points for the season in order to make the playoffs. A win is worth 2 points, a tie is worth 1 point, and a loss is worth 0 points. The team plays no more than 50 games. What are the possible combinations that describe this situation? And if we remember, guys, that in a system of inequalities that we don't just have one answer, that kind of makes sense then as to what they're asking here, right? Because we know that there's a lot of possibilities. So it's asking for all possible combinations here. Let's actually remind ourselves, what are all the possible combinations that describe the situation? Okay. All right. So what do we know? Let's actually go through here and figure out what we know. All right. So they need at least 60 points. All right. A win is worth 2 points. And a tie is worth 1 point. And of course, a loss is worth 0 points. I'm not even going to highlight that because if it's worth 0 points, I know that's not going to be worth anything and I'm not going to need to add that. Let's see, the team plays no more than 50 games. All right, so let's actually kind of try to isolate some of this information, but I need to read ahead. I'm going to read this and see what it says. Write 2 inequalities that describe the situation. Let W equal the number of wins, and it's telling us that the W is going to be the vertical axis, and T is going to be the number of ties, and it's going to be telling us that that's actually going to be on our horizontal axis. So and then assume all the wins and ties are greater than 0. So it's given us a little bit of background information, and it's also helping us to define our variables a little bit here. Okay, and if we go back up, we know, first of all, we know, get this up here, we know that we have to come up with 2 categories in our, to write our 2 inequalities, right? We know that. So let's actually, I'm going to write out a little bit of information here. I know that W is equal to wins, and I know that T is equal to ties. Okay, what else do I know? I know that there is a total of 60 points needed. And I've got wins, 2 points, ties, 1 point. And the last piece of information is no more than 50 games. All right, it's a lot of information here. So we're looking for our 2 categories. We can kind of start to see that kind of jump out at us as we kind of write all this stuff out, right? So let's see if we can figure out. We can see that this information is all in terms of points. And then we have this category over here of games, right? So that seems to be our 2 categories. So let's just say our first category is games, number of games. Or it should just be in terms of games, let's say. And the second category is going to be in terms of points. Okay, so that's going to help us to write out basically what we're needing to write out. This idea of no more than, right? No more than means it could be 50, but it can't be more than 50. So we need to also be thinking about what inequality sign would that indicate. Well, it could be less than 50, right? But it could be equal to 50. So no more than would be a less than or equal to sign. Okay, and how about this? I actually just neglected altogether to consider this. I just wrote 60 points. That was not right because it doesn't say equals, does it? The skating stars believe that they need at least 60 points. Well, at least means, right, that they need 60 or more. But 60 would actually work too. So they need more than or equal to 60 points, don't they? So this would be, I'm going to go back here and fix this because that, oopsie, is not true. This has got to be greater than or equal to 60 points total. Okay? So that's going to help us writing our equation out. So let's think about games. Well, wins and ties goes in the games category because that's the result of the games, right? I know that all of their wins plus all of their ties is no more than 50. So less than or equal to 50. Okay, so this is one of my equations, or my inequalities. Now let's kind of think about our points here. And remember, we're talking about something that is weighted. We have to have one of our categories weighted. So I want you guys to always look for that. Well, we know that. We know that every win is weighted at 2, every tie is weighted at 1. I kind of mentioned this when I was earlier when we were working on another problem. I mentioned this sort of thing. And I don't really need to write the 1 in here, but for now I'll go ahead and write it just so we can kind of see the weighting that's happening there. Okay, so for every win, 2 points, every tie, 1 point, and we need at least 60 points. So this inequality is written in terms of points. So there's my 2 inequalities that I'm going to use. All right, now I need to kind of think about a couple of different things. My vertical axis is usually my y-axis, right? So right now, though, they want us to put the number of wins on that, and they're asking us to put the ties on here. Like I said to you, if they don't specify, it's your choice. The one thing I just want you to be careful of is that when you are graphing these things, find out what your vertical axis is and double check that you don't have a negative coefficient there, right? Because if you did, you would have to rewrite that, divide out that negative coefficient, and it's going to flip your inequality sign, all right? But since you don't have that, you don't need to worry about it. Okay, so we can graph these by t-tables because you notice the w and the t are on the same side of the equation, so of course that always makes it an easy way to graph these. So our equation number 1, we can see really easily, whoops, not x and y, we don't have an x and a y. We have a t, which is our normal x, and a w, which is our normal y. Okay, when t is 0, w is 50. And the same is true when w is 0, t is 50. So that's a nice easy way to figure out that one. Let's go to our equation number 2. Let's color that pink. Let's do the same thing. T, W. All right, what happens when t is 0? If we plug a 0 in here, it's going to wipe out that term. And you're going to basically have w is equal to 60 divided by 2, right? Because we're going to just be dividing both sides by 2 here. So when t is 0, w is 30. That's one of your coordinates. And when w is 0, so let's put a w in there this time. I mean, 0 in there this time, which is going to mark that one off. And it's going to just leave a 60 here for our t. Okay, that's great. So once again, we need to figure out our minimum and our maximum based on the information that we have in our little table there. I'm going to go ahead and finish a couple things out here. Let me go back to my graph. I know that t here stands for ties, so I want to make sure that I remember to label that. Number of ties, course, here is going to be number of wins. And let's look at our t, our normal x-axis. Let's find our minimum and maximum. Looks like our minimum is 0, our maximum is 60. Once again, this is a 15 by 15. So I think we're safe to go by 5s like we did before. That will work just fine. 5, 10, let's skip here, 20, 30, 40, 50, 60, and I'll finish it out here at 70. All right, let's take a peek now at our W. Minimum is 0, maximum is 50. So I think we're good to stick with this idea of 5s. All right, this would be 10, 20, 30, 40, 50. And you guys can finish it out if you like to do that. There we go. And now we can go ahead and graph these. We've got 0, 50, 50, 0. Okay, and we have to go back up to our equation number 1 and look at what our inequality sign is. Right? So we have a less than or equal to sign. So we know that that is a solid line, and we're going to be shading to the left of that, aren't we? So let's do that. Okay, we have a solid line here. We're going to be shading below. All right. And our second equation, let's go ahead and use pink here. We've got 0, 30, and 60, 0. Okay, let's see if I can do this. Oh, and we have, let's look at our sign. It also has an or equal to, so I know I'm good with my solid line. Okay, and this time I am shading above because it's a greater than or equal. Okay, so I'm shading above here, but I'm really just interested in this area anyway, because this is our solution region right at the overlap, right? Okay, so what does this mean? What does this overlap mean in here? Okay, well, we can actually, we're asked to consider that down here in C. Describe the significance of the overlap region. Well, what does that really represent? Right, if we know that we've got wins on one axis, ties on another, basically, it shows all the combinations of wins and ties that are possible to gain at least 60 points in 50 or less games, right? So take a little bit of time to write that out, but shows all possibilities of wins and ties that are possible. I'm just take that all possible, possible combos. You can write that out better than that, but combinations of wins and ties to gain at least 60 points in 50 games or less. Right? So basically, we might pick a point in here and say, okay, let's go to 2025. Right? Here's one option, 2025. 2025. Well, this is going to be our T and this is going to be our wins. So 20 ties and 25 wins would be in that combination of possibilities, right? We could pick this point here, right there, 0, 50, right? We could have 0 ties, but 50 wins. Woohoo! That would be great. Okay, we could have 10 ties and 35, right? I mean, you guys get the idea here. lots and lots of possibilities here for our wins and our ties. And basically down here it's asking us to pick 2 points, one within our region, explaining what it stands for, we just kind of did that, and one outside the region and double check. Of course, inside the region we would want to make sure that that works, right? Oops, inside. We could double check the point 10, 30, or even you could even do a real easy one like 0, 40, something like that. Pick whatever point you want. I'm just going to randomly pick something, 10, 30. That's inside. And of course, it has to work for both. So you need to check that and make sure that it works for both. Okay? Outside. Well, it might work for one, right? If you were to pick a point over here, let's say, this would be 60, 15. Well, you can see because the shading is in this region for that second equation, it is going to work for one of your equations. It's going to work for that one, right? When you plug it into this second equation, it's going to work because it's in that shaded region, right? If you picked a point over here, well, that's in the shaded region for this first equation. It's going to work there, but it is not going to work for both, right? So any point that you check outside, it should only work for one or none. Should only work for one equation or inequality, or none, but not both. Okay? So I think you guys get the idea of how that goes. All right, guys, like I said, there will be more of these systems of equations that we will kind of revisit. The systems of equation application problems are something that are important for you guys to know. The system of inequalities are interesting, and it's definitely something that you guys should practice, but maybe not quite. I don't want you to stress out too much, so just give you a heads up there that they're definitely important, but I would like you to concentrate on the systems of equation application problems a little bit more. All right, guys, we will be talking to you soon.